This week, the week of December 14th, is the feature freeze for Java 12. Included in this release of arguably the most popular framework on the planet is the Shenandoah Garbage Collector, an experimental low-pause garbage collector for the JVM, aboardable mixed collections for G1GC, a proposal to enhance G1 to automatically return Java heap memory to the operating system when idle, a JVM constants API, improved startup on CDS and GC, a reduced number of ARM ports, switch expressions, and a micro benchmark suite. See Charles Humble's news post on InfoQ.com if you want more details. If you're counting, that was 8 different JEPs. That's a far cry from the over 100 JEPs that were included as part of Java 9. Hello, my name is Wes Reisz, and I have the privilege to host the InfoQ podcast. In addition to hosting the podcast, I chair a set of software conferences called QCon. QCons are senior developer and architecture-focused conferences held in places around the world like London, San Francisco, New York, Beijing, and Sao Paulo, Brazil. The next QCon is in London, March 4th through 6th in the Westminster area. Hope you can join us for 3 days of deep dives in languages, architecture, service meshes, and practices around things like machine learning, DevOps, and culture. Check us out at qconlondon.com. As you may have guessed on today's podcast, we're talking about Java. Specifically, we're talking to Brian Goetz. Brian is the Java language architect at Oracle. He is responsible for the future of the Java language and the core JDK libraries. On today's podcast, we're discussing a bit about the reasoning and the thinking behind the cadence in his own words. We'll talk about features found in Java 9, 10, and 11, and we'll spend some time talking about the features coming up with Java 12, to include Shenandoah, switch expressions, and the micro benchmarking framework. And finally, we'll talk about features beyond 12, projects like Valhalla, where value types are going to be introduced to the language, Ember, where local variable type inference came from, Panama, rebooting the native code interactions, and Loom, or support for adding continuations to the JVM. As always, thank you so much for joining us on the InfoQ podcast. Brian, thank you so much for joining us on the podcast.
Thanks, Wes. Nice to be here.
Since I have the opportunity here, the first thing I have to do is say, this podcast is being recorded literally a week before feature freeze for Java 12. There's 1,000 things you could be doing. So from the community, from me, thank you so much for taking the time to do things like this.
No problem.
All right. So let's talk a bit about that cadence first off. What does the 6-month cadence mean for Java?
So this turns out to be a huge change. And it's a change not only in the way we deliver the JDK, but it's also a change in the way we plan it. And it started out, we thought it was going to be a story about more rapid delivery and more predictable delivery. And it surprisingly kind of turned into a story about flexibility and efficiency as well. And so it's worked out, in my opinion, just better than we could have hoped. So the basic motivation is, the way we used to do it wasn't working, right? And the way we used to do it was we'd pick a big feature driver like Lambda or modules, and we'd take a wild guess as to how long it was going to take, and we'd be wrong. And then we'd have to turn around and say, oh, sorry, guys, we got to delay the release. And no one liked that. And, why does that happen? Well, it's really hard to accurately estimate how long it's going to take to do a big project that has some research components. So rather than making a bad guess and then being wrong and having to change the story, we wanted to increase predictability, but we also wanted to increase the rate at which we can deliver things, right? Because if you've got a 3-year release or a 4-year release, and you've got a little feature that maybe took 6 months to do, and it's done in the first 6 months, why should people have to wait 2.5 years for it?
Sure.
So we thought it was mostly going to be about predictability and about more rapid delivery. But as it turned out, it addressed another big efficiency problem that we sort of weren't even aware that we had, which was, if the next train's not coming for 4 years, you want to make really sure that everything that's supposed to be on the train is on the train. And that means a lot of release planning meetings. And those release planning meetings come at the expense of engineering work. And then, of course, what do people do, right? They don't want to miss the train. So they either work like crazy to try to get their thing on board and maybe, hurt themselves in the process. Or maybe they're tempted to cut quality to get something on board, and that's not good either. And now people just work on stuff, and when it's ready, it boards the next train. And we have no release meetings. We have almost no time lost to release planning. We just work on stuff, and when it's ready, it ships.
And everybody listening to this podcast can relate because everybody has had the big bang releases and everyone's had to come to terms with releasing smaller releases. But still, this is the framework. This is the platform. It's the underlying kind of stability that we all build on. So how do you answer that person going out there? But this is Java. We're not talking about web app.
Yeah, well, we thought that at first too. When this was first brought up, we thought, oh, that's crazy. We can't do that. And then we started to think about, well, how could we do that? And we realized that it was an opportunity to break things down into smaller pieces and to deliver big features as a group of smaller features over time. And then we started to realize the advantages of doing that. So for example, I'm sure a lot of your listeners have noticed that Java 9, with the advent of the module system, was kind of a disruptive release. And that there was some amount of work that users have to do to move their applications to Java 9. And if we could have spread that disruption over 2 or 3 years and maybe started to put warnings in the compiler 2 years before we were going to do something disruptive, it would have been a much less disruptive process.
So let's talk about that for just 1 second, though. For Jigsaw in particular, could that have been done with a 6-month cadence? I mean, that was such a disruptive, deep-reaching kind of change to the JVM. Could that have been done this way?
I think it could have been. There are pieces that were groundwork that we could have laid ahead of time, and there was tooling that we could put in place so that you would, for example, get compile warnings when you were doing something that was going to stop working in 6 months or a year and a half. And so rather than having everybody wait to see if their application breaks, if they start getting warnings now and they have a year to fix that, by the time the switch gets turned on, the disruption is less. I mean, obviously, some people are going to wait to the last minute and they're going to be in the obvious situation. But I think a lot of people want to get ahead of these things.
Nobody ever ignores deprecated warnings. They never do that. We're actually recording this a week before the freeze, but the release freeze for 12 is literally next week. So what's it like now around the Oracle offices prior to a freeze?
So it's totally calm. People are working on stuff, and yeah, there's stuff that they're like, want to make sure it gets in, but it's not remotely like the all hands on deck panics that, we had in the final weeks of a Java 8 or a Java 9, where we had big disruptive features that, all had to go in by a deadline.
Yeah, I can imagine. And for those of you who are listening, you can't see this, but Brian's at home, not in an office with 20 people behind him wanting him to get out of an office. So he's not fibbing there. So you mentioned as we were prepping for this that there's been a lot of unexpected consequences, such as your pipeline's better than ever. Can you elaborate a bit there?
Yeah, so this turned out to be a very pleasant surprise that if I look at the features that are in the pipeline now, it's better than it's ever been, and we feel like we have more control over how we're going to deliver those things. And so we have a lot of interesting things that we're working on, that some of which interact with each other. And by breaking things down into smaller pieces, we're able to deliver them in little chunks, which is great. But one of the things that happened with the old release model that was very frustrating was if you were working on a big feature like Lambda for 3 or 4 years, and that's all you're going to be working on, right? So by the time you ship that, you've got nothing in the pipeline, right? That you've just delivered everything you've been working on for the last 4 years, and now here comes the product manager saying, "Okay, so what's in the next version?" Meanwhile, no one has slept for weeks, right? And so that's a really bad time to have that conversation. But when you spend your pipeline, it takes time to rebuild it. And with the incremental delivery, we've been able to build back up our pipeline so that we have a really nice mix of features in the works.
We've been saying with moving to Agile all along, right? So it's just applying it to the frameworks.
Yeah. And it's surprising that it worked for something as a low level as the platform, and for something for which compatibility is such an important thing for us. But we've been able to make it work, and it's been great.
We're going to talk a bit about Java 10 and 11, what's coming up in 12, and then we're going to talk about some of the features out there like Valhalla and Ember and Loom. But before we do that, I wanted to hit on Oracle JDK and OpenJDK. They're essentially the same now, right?
Yeah, they're almost identical. Our goal is to get to identical binaries with 2 different licenses. And we've been working towards that for a long time. One of the big things that we've done is we took a number of features that had previously been closed source commercial features that were offered as a product that was called Java SE Advanced, and we've open sourced them all. So features that we used to do in the closed that we charged for, we are now doing in the open, and everybody gets them for free. And a number of the features that were in 11, and I guess in 12 as well, are pieces of that open sourcing effort. So flight recorder, mission control, ZGC garbage collector, these are features that were closed and that we are almost finished open sourcing now.
I want to ask you about other JDKs, Amazon's JDK and Red Hat's JDK. With all these different JDKs coming up, is it just competing on the performance of the JDK? What is the value prop of having all these JDKs for the developer?
Yeah, that's a really good question. So most of the distributions that you get are based heavily on OpenJDK, but OpenJDK is not one monolithic thing, right? It's a sequence, there's a sequence of change sets that get applied, and the various distributions can choose to apply or not certain change sets. So for example, if you look at the Amazon Corretto distribution, they take a certain point in the OpenJDK revision control, and then they say, now we're going to add 12 bug fixes. 4 of them are bug fixes that Amazon did and are in the process of offering to OpenJDK to be upstream. And 6 of them are backports of bug fixes that OpenJDK had applied to the next version, but Corretto decided to backport to a previous version. And so the differences between these distributions are largely which bug fixes are being picked up.
All right, so let's switch in now and start talking about the versions. Java 10 was the first release on the new cadence, also the first one post-Jigsaw. What's the significance of the Java 10 release?
Yeah, so, internally, we kind of looked at it as the proof of concept of whether the new release cadence could work. And so there was a little bit of worry internally of, well, what if we don't have any new features for 10? And it turned out that wasn't a problem. We had something like, 12 or so JEPs in 10, which for a 6-month release, you scale that up to our old cadence, that amounts to something like 70, 80, JEPs in a 3 or 4 year release. That's not so bad. And it included one language feature, which I think is going to be a super popular feature for developers, which is type inference for local variables. So I think for a lot of people, that feature alone justifies switching to Java 10, because a lot of people really want that. And it's kind of a good illustration of the tension that we have when planning things like language features, which affect every developers. We had some developers telling us, dude, it's 2018. Every other language has this feature. How could you not have this feature? You're so behind the times. And then we have other developers saying to us, you don't want that. That's just getting into fashion. It's going to ruin Java. It's just going to enable people to write bad code. And of course, we can only do one of these things. And so whichever we do, we're going to make some people unhappy. But I think it worked out really well. I think it's a small feature, but it's one developers like, and they've seen in other languages like C# or Scala or Kotlin, and they want it in Java, and it fit perfectly nicely into Java. So great.
So why only local? Why not at the class level? What was the kind of reasoning for that?
Yeah, so that comes down to a philosophical question, that the typing of a local variable is a pure implementation detail. And the fact that there's a certain loss of specificity in the code is okay from our perspective because that's an implementation detail. Whereas if you try to do type inference at API boundaries, now you're getting into compatibility concerns. That what you don't want is for a small change in the implementation of a method body to change the return type of the method body, and then you have compiled code out there that's calling that method, and all of a sudden that method doesn't exist anymore because its signature has changed.
So you listen to the community and said at the local level, we can do this in a way to give some syntactic sugar, essentially, but still keep the protection at the API boundary.
Exactly.
So let's talk a bit about that. How are these changes kind of getting surfaced? The process for how the Java language has evolved has been kind of a black box for a lot of people, me included, for a long time. What does this really look like today? How do you get changes, feature requests into the JVM versus Java?
Yeah, so it varies a lot depending on how intrusive the feature is and how many people it affects, right? So if you have a bug fix for a char set encoder for, an obscure character set, it's fairly easy to show up with a patch and tests and say, look, I've got a bug fix. Here's why I think this thing is a bug. Here's why I think my patch fixes the bug. And someone's going to look at that and say, yeah, that sounds good. Well, we'd be happy to have that. At the other end of the spectrum, if you show up with, I think we should remove checked exceptions from Java, well, that's a more disruptive change. And, the bar for explaining why you think that's a good idea to impose on everybody's Java is much, much higher, right? So language evolution is a kind of specialized skill set. There's a number of people, employed at Oracle who specialize in this. There's some people in the community who participate not employed at Oracle who also help us out a lot. But for the most part, big changes like language changes or VM changes are big enough that they're being driven by people who are working on this full time. And that makes a certain amount of sense because these are big projects with big risks. And you want to make sure you don't break anyone's Java.
So we're talking about Java language versions. We're talking about upgrades and changes. At the clients that I used to work for, we always had multiple JVMs that were running in production. Now with the 6-month release cadence, critics are going to say, well, now there's even more fragmentation of the JVM. Any concerns that are you seeing people upgrading with each of these intermediate releases? What are you actually seeing at Oracle?
We're seeing everything because the Java community is so large, right? Some customers who are ultra conservative and they're still running on Java 6 or something like that. And they're happy to just keep running the application with security updates. That's the only changes they want to make. And then at the other end of the spectrum, we see people deploying on not just the most recent release, but on OpenJDK tip builds. And we see everything in between. And, I think that makes sense, because different customers have different risk tolerances and different degrees of willingness to take additional deployment risk to get features that they want. And what we're seeing is a lot of people are bundling their app with a JDK in a container. And so the model that we used to have, which is you had a JDK installed on your system and you had to run on whatever was installed in your system, that's gone away, right? Now, a lot of applications are bundled with exactly one version of the JDK that they test with. And when they upgrade, they are building a new container, running tests against it, and certifying that. So I think it makes it easier for people to make the decision about which version to use on a much finer grain level rather than it being the big corporate-wide decision that it used to be.
All right. So 11 went GA in September. One of the big things that I saw, it dropped modules for Corba, yay,
yeah,
and some Java EE ones. It also brought HTTP client into full release. I believe with Java 9 is when it came out in an incubating status.
Right.
I wanted to talk a bit about that. What does it mean to be incubating, and why is it bundled with Java SE?
Yeah, so that's a great question. So, as the release cadence gets smaller and smaller, the time between releases is also smaller, which means the time to get feedback from people is also smaller, right? So when we were developing Lambda, which took 3.5 years, there were a lot of people trying it out in the interim and giving us feedback. In a 6-month release, we don't have that luxury. And so what we need in order to make sure that we've gotten all the feedback we need and acted on it is we need some extra stages in the delivery pipeline so that something can go from crazy idea to prototype to beta quality release to being a final and permanent part of the Java platform. And so for libraries, we have this notion of incubator modules, which are libraries that we think are stable enough to try out, but not necessarily recommending people use in production. But the primary purpose of bundling it with the JDK is so that people can see where we're going and give us feedback before things freeze. Because there's this terrible chicken and egg problem where a lot of people say, well, I'll try that out when it ships. Well, by the time it ships, it may be too late for people to report back their feedback in a way that can affect the outcome.
But why not as an external kind of library that you can download or module that you can download and be able to incorporate? Why actually as part of Java SE?
We could go either way, and we may end up at some point switching the way we do that. The incubator module mechanism was something that we developed when we were still doing Java 9, and we were still sort of thinking in terms of the older release cadence. And so we didn't have an alternate distribution mechanism in mind, and we knew a lot of people wanted the HTTP clients, and we wanted to get it into those people's hands, but we also were aware that the version that shipped with 9 wasn't finished. And in 11, now we shipped a version that is finished. It's a permanent part of the platform, and it's something that we can recommend people use in production.
Yeah, makes total sense. Okay, so a few other changes under the hood. I know there's some changes with string. Anything in particular that you'd want to highlight with 11?
Well, so I want to call attention to Flight Recorder and ZGC. These are really powerful mechanisms. Flight Recorder has been around for quite a long time as a commercial feature. ZGC is something that we were developing as a commercial feature, and both of those have been open sourced and released in 11. ZGC was released as an experimental option in 11. Flight Recorder is a full production feature in 11. Flight Recorder is an amazing monitoring tool where the JVM maintains what is basically a circular ring buffer of events that get generated by all different components of the JVM. And ordinarily, after however much memory you allocate to it, 5, 10, 15 minutes worth, whatever, it'll just ring buffer and start overwriting old events. But you can set up triggers that say, when a thread throws an unexpected exception, or when some unusual event happens right before a garbage collection pause, whatever, I have it dump these out to a file or send them to a monitoring station. You can get really good information about what's going on inside a production running VM. And the performance overhead of having this on all the time is like 0.5%, right? It's really down in the noise. And so it's a really effective way of looking into what's happening in your systems in production. As we open source it, it will also be possible for libraries and frameworks to feed events in as well. So you'll get a nice holistic view of, well, this happened, and at the same time, this other thing happened, and be able to conclude maybe these things are related.
Very nice. All right, so let's switch in to talk about 12. Included in Java 12, we've got Shenandoah, also a low pause GC. We've got JVM Constants API. We've got a micro benchmarking suite and like 8 other or so JEPs. So let's start off with Shenandoah. What's the sweet spot for Shenandoah?
So Shenandoah and ZGC have a lot in common. They're both aimed at the low latency use case. And with garbage collection, like everything else, there's no free lunch, right? There's always a trade-off between latency and throughput. And some customers are sensitive to latency and some customers are sensitive to throughput. And that's one of the reasons why there are multiple garbage collector options and so many tuning options in the JVM, because there's just no one-size-fits-all algorithm that's perfect for everything. ZGC, like I mentioned, was a product that we had started working on as a commercial thing, and then we open sourced. At the same time, Shenandoah is being developed in the open, primarily by Red Hat, and the two have been sort of developed in parallel and both landed as experimental features at roughly the same time.
So while they both may have similar use cases, it's basically just a matter that you're not specifying what you should use. You're providing both garbage collector options and your mileage may vary. Use what works best for you.
Exactly. And they both make some slightly different trade-offs about what, the use cases and workloads that they're kind of aimed at as a sweet spot. And so there are going to be some workloads where one or the other is, shows some relative advantage.
What about the micro benchmarking framework? I'm actually not familiar with what it does.
Yeah, so that's another piece of the open sourcing of stuff that we had going on in the closed, right? So we have, as you can imagine, an extensive performance monitoring suite for the JDK so that we can identify, oh, look, this change set caused a regression in string comparison performance or whatever. And we have a number of dedicated systems running these performance tests all the time. These micro benchmarks are smaller performance tests aimed at a particular activity. And we open source them and gathered them together into a suite so that people outside of Oracle can run them as well.
One of the other new concepts that are coming with 12, I believe, is a preview feature. What does that mean?
Yeah, so a preview feature is sort of the analog of incubator features for language and VM features. So incubator is largely about the libraries. Preview features are about things that are core to the platform, the language and the JVM. And preview features, the bar is a little bit higher than it is for incubator features. The idea is that this is a feature that really should be done. It has a full specification, implementation, compatibility test suite, all of those things. But we want to give it a 6-month grace period for people to try it out and give us feedback, just in case there's something we didn't think of. And people come back and try it and say, I tried this and it worked really badly in this case. And we say, oh my God, we didn't think about that. We have an opportunity to change it because it's possible to deprecate a library. It's really hard to deprecate a language feature.
So are these like feature flags that are in the language that you can disable and enable?
They are like feature flags, except they all turn on at once or all off at once. And so you either say compile with preview features enabled or compile with preview features disabled. And the IDEs have the same support. So if you go into IntelliJ, you go to the language level picker, it'll say, 11, 12, 12 with preview. And you can turn those on in your IDE as well.
I think one of the language features that are probably going to be most visible for a Java developer developing on Java is going to be the changes to switch, the expression switch. It's always been, at least we'll call it creative challenge sometimes to make switches do exactly what you want it to do. So talk a bit about the expression switch and what's going to come in 12.
Yeah, so this is the first preview feature we're doing. It's expression switches, and is what it sounds like. It allows you to use a switch as an expression as well as a statement. What we discovered, by looking at the code people write, is that most switch statements in Java really wish they could be expressions, but they can't. And so we kind of tie ourselves in knots trying to simulate expressions with statements. And that, is more code to write, and it's more error prone. And so this is a let people say what they mean kind of move. And the result is more compact code, but also more reliable code that can be type checked better. And this feature grew out of, or sedimented out of, a bigger feature, which is pattern matching. So we had started working on pattern matching as part of Project Amber, and that's a pretty big feature. And this was a sort of small sub-feature of that we needed for pattern matching, where we were able to say, the expression switch stuff, that's done. Let's ship that, and let's keep working on the pattern matching stuff, rather than making people wait 3 more years for that.
So this kind of segues into longer term projects with name, like you just mentioned Amber, for example. Valhalla is one that a lot of people have probably heard about. I wanted to talk a bit about how do these projects relate to the 6-month cadence, like the train projects? How do they kind of map together?
Right. So almost any non-trivial feature is going to take more than 6 months to do. So it's not like we're going to start a feature and end a feature in that same 6-month window. That almost never happens. So we have a lot of work that's going on in these longer term side projects, and they have their own separate repositories and their own mailing lists where we're exploring, designing, prototyping, and then when it looks like one of these features or sub-features is ready to board a train, then we will extract that out and commit it to the main line.
One that I'm most familiar with is Valhalla. I actually expected Valhalla was going to be released in 10. And when we were prepping for this, I actually made comments and said, I haven't actually played with value types. How did that work out? And you're like, well, it's not actually there yet. Didn't board the train yet. When will value types be released?
So that's a great question. And that's kind of a nice way of saying, gee, Brian, you've been talking about value types for like 4 or 5 years. Are you guys working on this at all? So I appreciate that. But, the excuse that I give is, when we announced this project, there was a panel at Java One, and James Gosling was there, and he was very supportive of value types. He wanted to do them from day one. But he turned to me and he said, you realize that you've just signed up for like 6 PhD theses braided together, right? And, like most things, he was right about that. This is a big, big project. We've been working on it for over 4 years. We're on our 5th prototype. And we're actually starting to approach something that someone might want to use, but we're not done.
So those people who haven't followed, why are value types important?
So value types are important because the world of computing changes out from under us. The hardware that we run our programs on has changed, and it's changed a lot in the last 25, 30 years. So, if Java was first released in 1995, so they started working on the design in 91, 92. So think about the hardware reality of 1990, let's say. In those days, processors were pretty simple, memory hierarchies were pretty simple, and you had these data books that told you this instruction uses this many cycles, and a arithmetic operation and a memory fetch used like the same amount of time. Whereas now, processors have gotten so complicated that the performance difference between a memory fetch and an arithmetic operation has increased by like a factor of 1,000. We're running on very different hardware than we used to, and the way that we do things has to change as well.
You said you're on your 5th prototype. Do you happen to have any idea what the performance looks like using value types?
Yeah, so one of the reasons why we did so many prototypes, by the way, is there are so many different aspects of this, of how it affects the language, how it affects generics, how it affects the JVM, and each prototype sort of focused on a different aspect of it. So the most recent prototype is, I would say, the first one that you could actually write what looks like normal Java code with it and get the benefits. And so we picked an example that we knew was kind of a stacking the deck example, where we said, all right, supposing you have complex numbers, where the real and imaginary components are 64-bit doubles, and you want to do matrix multiplication on these. And so we wrote the obvious, write a class for complex, and then write a value class for complex, and write a driver to benchmark multiplying some 500 by 500 matrices, and then look at the performance counters. And not surprisingly, the value version beat the non-value version by a factor of like 12. And, that's because not only did it not have to do all that boxing and allocation and all of that, but also we were able to keep the core a lot busier doing arithmetic and not spend as much time waiting for the memory subsystem to cough up the next bit of data to operate on. And when you turn on like performance counters in the chip where you can see a lot of low-level information, what you saw was you went from doing like one instruction per cycle to doing like over 3 instructions per cycle. And that was showing how, yes, we're actually in the chip, we're doing all of these multiplications concurrently because it can do like 4 simultaneous arithmetic operations. And you're actually able to keep it fed fast enough to sustainably get that kind of rate. So it's a really nice thing to see.
Very nice. So in addition to Valhalla, you mentioned Amber, for example, a little bit earlier. And if you listen to George Sabb's keynote at Oracle Code 1, he also talked about Amber and Loom and Valhalla and some of these other things. So I wanted to talk a bit about those. So value types is kind of part of Valhalla. What about Amber? You mentioned that a little bit earlier. What is Amber all?
Yeah, so Amber is a sort of umbrella project for all of the smaller language features that everybody always asks me about. So, local variable type inference was the first feature that came out of Amber, as was the switch expressions. And we've also got a number of other explorations going on in Amber, including pattern matching and more concise class declarations. So these are sort of the language, I don't want to call them syntax features because they're not all syntax, but they're about productivity and expressiveness and keeping the language vibrant and fun to use.
So Amber is kind of like an umbrella project where things are matured, developed, and as they come to fruition and a train's coming out, put on the train, they're kind of pulled out and the project just decreases by that. New things may come in, but that's kind of what these projects are used for.
Yeah, that's exactly right.
Okay, so another one that I find particularly interesting is Loom. So continuation, things like bringing coroutines into Java. Can you talk a bit about Loom and what its goals are?
Yeah, so Loom is kind of a bit of a newcomer, but it's in the last year has done some amazing things. And the goal is basically to add support for delimited continuations in the JVM and then expose that into Java libraries through a mechanism like fibers. And the reason this is important is again, it's one of these things where the way we use computers in the last 30 years has changed a lot, right? So if you look back 30 years ago, the way we dealt with asynchrony was you would say issue an asynchronous IO operation, and then you get an interrupt when it completes. And then you do a bit of work, and then maybe you issue another IO, and you wait for the completion interrupt of that. And that was pretty effective, except that it was impossible to read your code because your code was scattered all over. And then threads came along, like in the early 90s, and it was awesome because all of a sudden now your code became readable again because it gave you the illusion of sequentiality. First do this, then do this, and maybe it stops and waits in the middle, but you can read the code and it does what you think it means. And Fibers is playing the same trick again on threads. Where we run into now with threads is that threads over time have become more heavyweight than we want because a thread in the JVM is like a megabyte scale entity. It has big chunks of memory for stacks and various other data structures. And maybe you can get a few thousand or 10,000 threads running in JVM, but you can't get a million running in a JVM. And if you want to be able to handle a million concurrent requests, you need a lighter weight mechanism. And a lot of people are reaching for things like reactive APIs, but they kind of result in that same kind of hard to read code I was just talking about from the 80s. You want to see the whole workflow of what happens in what order, and Fibers pull the thread move again, allowing you to take that, reactive code and turn it into sequential looking code.
So what is a fiber though?
So a fiber is a lightweight unit of execution that borrows a thread when it needs to do some computation. So you've got a pool of threads and a scheduler and a fiber, which represents a task. You start that going, maybe it hits a blocking IO somewhere deep in the Java libraries. It says, oh, I hit a blocking IO. I'm running a fiber. I'm going to park that fiber, and I'm going to resume a different fiber on this library thread so that I can share these threads among multiple activities.
So it's a coroutine, right?
Yeah.
Like what Go's done, what C# done, what Kotlin's done. Okay, so in all those cases, and in particular, like with C#, there were syntactic language additions, async and await, to be able to make the changes. Are fibers going to modify the language to be able to introduce these, or what's the thinking there?
So there's two ways to go here. So C# and Kotlin went in one direction, and Go went in a different direction, and the direction we're going in is more like the Go direction. So in C# and Kotlin, what they did was they said, we're going to have a notion of an asynchronous task in the language. And so it'll have these well-defined points where you say await or yield. And there are certain things that you can't do in async code. And then the compiler will shred the code for you into a state machine. so that when you think is a call for the method is really a call to this modified method, which does a little bit of work and then spits out an answer. The continuation approach is less restrictive in that there's nothing you can't do in a fiber, but it requires support deeper in the runtime. So what C# and Kotlin do are all done in the static compiler by transforming your program. This is a feature of the JVM that's actually happening in the runtime, and that's what Go does as well.
So there's no added overhead on the developer in using this in particular. You just use it like you would any other code.
Yeah, there are some open questions that we haven't yet answered about how much are we going to support existing code that thinks it's running in threads but is actually running in fibers. And that's one of those trade-offs of the more we do to support that, the easier it'll be for people to migrate their code, but maybe we're giving up some performance or some features, by tying ourselves to that old model. And so we're kind of going back and forth on the design there of exactly how much are we designing this for migration versus how much are we designing this to be the next cool thing. And, those discussions haven't yet settled out.
Panama is all about kind of rethinking the interaction with native code JNI. What's the goal with Panama? What are you focused on?
Yeah, so, so Java always made it possible for you to call out to native C code and to access code in the native heap, but never made it easy. So you can use JNI, the Java native interface. It's not easy to use. It's really easy to mess up. It's error prone. And so you have to really want it if you want to go native. It's also very hard for the JVM to optimize JNI calls because it has no idea what's going on the other side. And so we kind of decided a few years ago that it was time to reboot our interaction with native code and native heap because there are certain things that are much easier to do on the native heap. And there are some native libraries out there that people really want to use, and we want to make it easy to call those from Java. And so Panama aims at making this interaction a lot easier and, more importantly, a lot safer. So there's kind of like two layers here. The lowest layer is just about being able to invoke native methods, get callbacks from native methods back to Java methods, and access data in the native heap. And the approach that we do that is there's a metadata for specifying the calling format that's completely like language neutral and platform neutral. So you can put that in your application, and then at runtime, the JVM generates code to do that on whatever particular machine that you're on. And then on top of that, we've got some tools that are really cool where you can point this tool called JExtract at an H file, and it will generate that metadata for you. So you say, I want to use that native library over there. There it is. Point the tool at it. And here are some parameters for tweaking what it generates, and out pop Java interfaces that you can just call.
What are we looking at for that? Is that in the near term, long term? How far away are we?
So that's coming along pretty nicely. I'm guessing that, we should be seeing previews of the lowest level piece in the year-ish time frame. It's coming along really nicely.
As I was reading through the concise bodies JEP, for example, I noticed something that stood out to me and said C#6 introduced expression bodied methods to support the single expression form of a method body, but with a fat arrow equals with a greater than, rather than a thin arrow dash with a greater than. Kotlin also supports this form with a single expression factor. One of the things that kind of really stood out to me with that is just interaction and kind of standing on each other's shoulders and the work different compiler teams are doing, like between the CLR, or the Beam VM, and the JVM. The truth of the matter is we kind of grow from each other. We learn from each other. We stand on each other's shoulders. It's not a religious war on the teams like it so much is with people that are maybe using the languages itself. Any comment on that?
Yeah, that's absolutely right. Java developers and C# developers have a lot in common. And there's not only a lot we can learn from each other, but we're also both coming from common influences. And so we have a lot more in common than we have different. I mean, we do have, some differences in approach or culture in one community or other that might make a solution make more sense in one community and less sense in another. But for the most part, we're solving a lot of the same problems and we're discovering a lot of the same answers. And I see that as much of a validation as anything else.
Okay, so what are the trends that you're seeing affecting Java over the next 20 years?
So, everything, right? People want faster performance, faster startup, better garbage collection, more expressive programming languages, better container behavior, you name it. The more things you try to do with the system, the more things you discover that, you'd like to also have it do this and the other thing. And people push things as hard as they're going to. And so the answer is always more, more, more.
What about like accessing GPU versus CPU? What's in the pipeline for kind of making some of the AI workloads faster with Java?
So there was an experiment called Project Sumatra aimed at compiling stuff down to the GPUs. And that one wasn't a super successful experiment, but we learned a few things from it. But one of the things that sort of grew in the shadow of it is some work that is collaborative work between Oracle and Intel to expose vector operations up into the programming model. So the Intel chips these days can do some pretty impressive vector operations, but how we write code to make that happen has always been hard. So, the ideal, of course, would be to have an auto-vectorizing compiler that automatically figures it all out and feeds it to the vector processor. And sometimes compilers can do things like that. But more often, the programmer needs to provide some hints about, here's an operation I'd like to vectorize and write it in a certain way that makes it amenable to vectorization. And I think that's going to be the case for all of these alternate computation models, whether it be vectors or GPUs or FPGAs, for quite a long time.
All right. Well, we're just a few days from the end of the year. Any New Year's resolutions for Java and the JVM? More. Well, Brian, thank you so much for taking time. Again, I can't stress enough. I know 6-month cycles, and you're running a platform that I think has 6 million developers using it worldwide. I think that's the number. And still, you take time to come out, speak at conferences, talk to us, be on the podcast. Thank you so much for taking the time to do that.
Thank you, Wes.